Henry Benoff, DC Lab 8. In this lab right here, we're going to be working with IC chips, and the particular chip that I chose today was the L293 Delta. And basically what this chip is it's an H-bridge chip, which is basically is able to drive two motors and basically increase the current in that chip through resistors. And in this lab right here, I'm going to show you that it's going to drive this one motor in the left direction, one motor in the right direction, and both motors in the same direction, either left or right. And one simulation, I'm going to show you the motor going or simulating a turning motion of it. And right now, I'm going to go ahead and set my meter back up. Turn it back to DC amps, because I'm going to show you the amps on here. I might as well show you right now. Right now, I'm going to show you the current amps on here. Right now, we got 0 amps, but as you can see right now, it's only being powered off the Arduino, and we got about 12 amps or so right there. Milliamps, I should say. I'm sorry about that. When I connect my 7-volt power source in there, it's going to increase the amperage up to roughly around 1.5 to 1.8 when it turns up, because of the transistors and how they arrange in the IC chip, either parallel or series arrangement. Basically, I got this this IC chip powered by the Arduino, and my 5 volts for my enables 1 and 2. I got them coming off these pins right here, but that's another, that's more like programming lab. I'm gonna just try to stick as close to the DC lab as possible. And we're just gonna go ahead and get it rocking right now, okay? And over here on my computer screen is basically telling you which direction that the motor is gonna be running in, either forward, reverse, or pump your brakes, stop, whatnot. And right now we're just gonna go ahead and connect our power source to it. And when I connect the power source, we already saw the amperage on there was roughly about 15 milliamps when it was only being powered by the 5-volt source. And as you can see, when it was powered by the 5-volt source, it could not rotate both motors at the same time, or it could not even rotate one of them unless you give it a little boost. But that don't even work here. But anyway, I'm gonna go ahead and connect my power source to it right here. And we're gonna take another amperage reading on it. And right now we currently stop. Now we are running forward. And as you can see right there, we're gonna wait. Okay, there we go. Our amps, roughly about 1.5 milliamps. And right now, we're gonna wait till it stop. We're gonna wait a minute. They both should be going in the same direction. Yes, they both turn into the left direction here. And the next one, they both turn in to the left direction, the right direction, simulating going backwards. And they both running in opposite direction here. And these are some of the options that you are able to accomplish if you got the DC and the programming lab. If you're taking both of those labs together. And basically what this L293 Delta chip is good for is basically if you want to like operate a small toy car, you can operate that car forward, reverse, or you can turn left, or you can turn right. It depends. With the programming knowledge and the DC circuit knowledge, you're able to do this with this particular chip right here. And basically, again, this chip right here is a H-bridge chip, and it's capable of running 2 motors in either the same direction, opposite directions, simulating the turn. And what it basically does is, in my opinion, it only increases the amperage within the circuit using the external power source. Because our Arduino is only capable of delivering something like 500 milliamps, I think. And right here, this right here increase your milliamps roughly about 600 or 1.5 milliamps when you're running both DC motors at the same time or in the same direction, opposite direction. It doesn't matter. That pretty much does it on this lab. I think I summed everything up here, and we can take one more reading on this meter and show you that it basically increased the current there. And as you can see, 1.4, 1.5, you know, that's that on that. I really don't know what else to tell you about this chip, but it have a lot of transistors in there, and depending on the arrangement of those transistors within the chip, you either gonna get a high current or a low current. It depends on the arrangement, and within this chip you have AND gates, OR gates, NOT gates, and within the IC you have a little thing in there that basically simulate an op amp or op current symbol in there, which only indicates that the current is either positive or negative or PNP or NPN. That basically does it for this lab here. I mean, I got it to work, and I just got it to work. And that does it for this lab. Henry Benoff, Lab 8 DC circuits, IC circuits. Thank you. Bye-bye.